Now next portion will be when I consider, that is number 7, a system matrix having the value 2, -3, 3 and 2. So in previously we were already discussing about this particular case when I had a system matrix which received lambda equals to -2 as my real portion and plus -3i a complex conjugate, which indicates that it will have a spiral in nature, the trajectory, and because of this -2 it will be exponentially decay, means it will converge to origin. So we had trajectories in this way, and the name of this trajectory, or rather the equilibrium point for this case, will be stable, focus or spiral. Next, when we consider a system matrix this, by using the concept lambda I minus a equal to 0, this will give me a lambda as plus 2 plus minus 3i. Now because of this plus minus 3i, this will indicate that I have a sine and cosine term, which is the reason my phase trajectory would look spiral in nature, not a straight line. And because of this plus 2, which indicates that my spiral should come away, or should come outside, or rather away from the origin. So it just look like this. I should draw in the opposite way. It should come from the origin, outside the origin, and then it should follow in this way. This is the phase portrait for the case when lambda will be a complex conjugate, have a positive real side, and it is, since it is coming outside the origin, it is named as unstable, focus or spiral. And the last point will be when I have a complex conjugate with 0 real part. So the classification which we already had, we considered that there will be a positive, that is one will be a positive real part, negative real part, and last will be the 0. So for this case also, I consider system matrix to be 0, -5, 1 and 0. So here, just using this concept, my lambda will be plus minus of root over 5i. I do not have any real part, only a complex conjugate part here. So for this case, what do we see? That it will just look like a circle, which means my x and y axis, which were considered as a phase variable, they will be having an equation which will satisfy my circle, that x square plus y square. That's the reason we will be having phase trajectory which would look like this. It will not be having any real portions, so that's why it will not be either converging or diverging, but it will just satisfy the circle, and depending upon either it's a clockwise or anti-clockwise, depending upon the magnitude of the sine and cosine terms, we'll be able to identify whether it is a clockwise or anti-clockwise. So whenever the situation where we consider that we have a system matrix having its eigenvalue without any real portion, only complex conjugate, it will behave as a circle, or rather the equation will satisfy circle. So the phase portrait would completely look like a circle, and its center neither enters the origin nor be out from the center. Therefore, such type of situation, the equilibrium point is named as vortex. So these are the different ways by which, if we have different types of eigenvalue, we can identify whether your phase portrait will be a straight line, or it will have family of straight lines, whether it will be a spiral or whether it will be a circle. Now, if we sum up the entire portions together, whatever we have taught in the entire video, then we can write it as in the form of tabular. Name of the equilibrium point, This is location of the characteristics equation, and lastly face portrait. So the first case will be stable node. For stable node, location of this will be, I will have 2 eigenvalue on the negative side. So when I have 2 eigenvalues on the negative side, we consider it as roots are real negative. So the face portrait would look like this. It will be having equation, it will have a curve, straight line, and that would be actually, since it is negative side, so these will be entering towards the origin. So it would just look like this. So it would just look like this, means you'll have one face portrait here, another one here. This would look like this. Rather, if I draw in a different color, this will be, and this one. These two are my face portrait. Secondly, number 2, which is unstable node. Unstable node is where roots are real positive. So the location of the characteristics equation will be like this, and my face portrait would look like this. I will be having an equation like this. Since it's positive, these would move outward, and my face portrait would look like this. So this is my face portrait. Next, we move for the next part, that is number 3, or I should write name of the equilibrium point, then location of characteristics equation, and finally face portrait. So next, number 3, it is saddle point. Saddle point says roots are real equal with one is positive and other negative. So I will be having characteristics equation, one on the positive, another one on the negative. So naturally I will be having 2 equation which will have one on the negative equation, another one as a positive equation. The first one we can say it is having entering. Now the one which is on the negative side, that will be converging towards 0 or origin, and the one which is positive side, it will be away from the origin. So my face portrait would look like this, starting from here, this way, this way, this one, and this is termed as saddle point. Number 4 will be stable focus or spiral, which is having the location having a complex conjugate but with a negative real axis. In that case, we will be having a face portrait will look in this way. We are marking down the phase variables, which is very, very important. Otherwise, we might lose few marks there. We have one variable, another one derivative of the other variable, keeping in mind that those particular state variables derivative will be equal to 0 to satisfy the equilibrium point. So this is my phase portrait in case of stable focus or spiral, which has been, we can see that it is converging towards origin. Next will be point number 5, which is unstable focus, which is having a complex conjugate characteristic equations eigenvalue, but with the positive real portions. In that case, if we try to draw the phase portrait, it will just look in the opposite way. If you draw in this way, you can start from the origin, and since it is in positive side, so it will start from the origin and go away from it, and arrow on the outer side indicating that this is an unstable focus. And the last but not the least will be point 6, which is vortex or center, which is having marginally stable and oscillatory in nature. So in that case, you would be having complex conjugate eigenvalue, but with no real or no real positive or negative value. So it will be on the imaginary axis, and for that it will be satisfying the equation of a circle. Therefore, the phase portrait, when we draw the phase plane with the phase variables as E and E dot, just if you want to write X or X dot or X and Y, so it will be looking just as that of a circle. And in such situations where we see that we have a complex conjugate eigenvalue without any real positive or negative values, in that case the equilibrium point satisfying this phase portrait will be named as vortex or center with marginally stable, and the nature will be oscillatory. I hope the video will be very much helpful for you while explaining the phase plane. Thank you.